When a satellite reaches the end of its operational life or becomes non-functional, which is determined by its orbit and the forces operating in the expanse of space. As a satellite is an artificial entity, dying, in this sense usually refers to the end of its operational life rather than biological death.
Older satellites may undergo one of two outcomes: either they will burn up in the atmosphere or their engineers will spend the last of their fuel to slow them down until they fall out of orbit. Here is a detailed explanation of what generally happens when a satellite reaches the end of its mission in the universe. 1. Ceasing operations. The first step is to cease all operations on the satellite. This involves shutting down communication systems, scientific instruments, and any other active components. The satellite may no longer be able to fulfill its intended mission or provide useful data. 2. Orbital decay or change. Satellites in low Earth orbit, LEO, are influenced by atmospheric drag, causing their orbits to gradually decay over time. When a satellite's altitude decreases due to this decay, it will eventually re-enter the Earth's atmosphere and burn up. This process is more common for smaller satellites or those in lower orbits. 3. Graveyard orbit or disposal. Satellites in higher orbits, such as geostationary orbit, GEO, may be moved to a designated graveyard orbit or a higher orbit that minimizes the risk of interference with operational satellites. This process helps in clearing valuable orbital slots for active satellites.
When a satellite's mission comes to an end, it is typically decommissioned and moved into a graveyard orbit. This is a higher orbit, far away from operational satellites, where it can safely remain without posing a risk of collision. The process of moving a satellite to a graveyard orbit is known as passivation.
5. Long-term orbits or interstellar space. Some satellites, particularly those in high Earth orbits or beyond, may remain in orbit for an extended period, becoming celestial artifacts in the vastness of space. Eventually, gravitational perturbations from celestial bodies or other forces may alter their trajectories, leading them to explore interstellar space or collide with other celestial objects.
Unlike on Earth, where death leads to stillness, in space also the end of a satellite's operational life marks the beginning of an unpredictable tumbling journey around the planet. And it's also called in-orbit tumbling analysis, which seeks to predict the attitude motion of non-operational satellites. This celestial dance of inactive satellites poses a challenge for the European Space Agency (ESA), which aims to clear the orbits of these potential hazards. The initiative strategy, known as active debris removal (ADR), which requires precise knowledge of the object's orientation and movement to successfully capture and remove it from space. Over 2 years, the project meticulously observed more than 20 objects using a combination of optical, laser ranging, and radar observations. Gravity gradients and eddy currents are the main factors affecting satellites in lower orbit. Conversely, individuals positioned in higher geostationary orbits, particularly those with extensive solar arrays, are more vulnerable to the gradual but continuous pressure exerted by solar radiation. The study revealed that a variety of factors contribute to the tumbling of satellites. Eddy currents generated by interactions between internal magnetic fields and Earth's magnetosphere, atmospheric drag, gravity gradients, outgassing, fuel leaks, solar radiation pressure, micrometeoroid impacts, and even the movement of any remaining fuel on board can all influence a satellite's post-mission behavior. Rather, these spacecraft engage in a final fuel burn, which places them in cemetery orbits. As of right now, spacecraft must be elevated to an orbit that is at least 300 kilometers higher than the busier operating orbits below in order to comply with U.S. requirements. The NOAA satellite GOES-12 was the most recent to be retired into a cemetery orbit. After 3,788 days of operation, the last movement took place in August 2013. The satellite's equipment and subsystems are turned off, the fuel runs out, and they are left to orbit peacefully until they reach this last orbit.